Hi, everyone. Nice to see you. My name is Gil, and I will be talking about TDD for two sessions, one today and one for tomorrow. Today, we're going to talk about test-driven development in legacy code. Is it possible? Well, the next 45 minutes will prove. I brought Kamit, who will help me in this slide. I hope you're enjoying JCON. I enjoy JCON a lot, and going to be it tomorrow as well. A bit about me. My name is Gil. I'm from Israel. I'm the author of two books, Everyday Unit Testing, Everyday Spring Testing. I'm a trainer and a consultant, and all kinds of things relating to developers and testers, everything between, and including testing, clean code, TDD. Things we're going to discuss here today. You can get in touch with me at this email address, gil@testinggil.com. Go to my site, testinggil.com, or everydayunittesting.com, name of the book, or tweet at me at Twitter and use the hashtag JCON2022 when you do that. So, if you have any questions, I'll try to write them in the chat, please. I'll try to look at it on the other screen while I'm doing this, but probably I'll do that at the end. I hope I'll be able to answer some questions. Let's start. So, test-driven development. You've probably seen this kind of circles before. Test-driven development is basically an iterative method of writing software. It's not about tests. It does use tests, but it's really about writing software. It's basically the best way I know to develop a working software. And I'm going to assume you know it, but for a couple of slides, I'm going to show what it is. So the idea is that you go through stages, like in life, red, green, and refactor. Red means you write a test and it fails for any reason. It won't compile, it wouldn't pass because it doesn't have any code. Data is not ready yet, it doesn't really matter. And then you pass the test in some way, and then you refactor. The simplest way to use it is like everybody on the internet shows you, is with calculator examples, of course. So I'm not going to be any different than that. So this is a JUnit test. You see a calculator that can add two tests. We have squiggly lines that tell us that the calculator is not defined yet, the class doesn't exist yet, and if this doesn't exist, the add method doesn't exist either. So we add code, like a calculator class and add method with the same signature, add the I plus j thing to calculate 3 plus 5. And then we refactor because I and j are not good enough names. We rename them for first name, first number, second number. Everything's good, everything's great. So why isn't everyone working with TDD? Well, it looks like it's easy on the examples on the internet, but when you go back to your work and you have a pile of legacy code that's been working for the last 5 or 10 years, and code is matched up together, and nobody likes that code, and it doesn't look like your calculator from the browser. So most people like look at these examples and say, well, you know what, probably works for other people, not me. And one of the things that I want to get from this session to you is that it's probably, you can do this, maybe not as exactly as the examples say. I'm going to start with the reasons that it's not like that. So like I said, first of all, examples are too simplistic. You look at the calculator. I'm going to show you examples with calculator, only the calculator doesn't look exactly like that. Most code is not in one place. So when we're talking about refactoring logic, for example, which makes sense, building new functionality into our code, usually TDD is like a unit testing thing. I'm going to show you how to use the principles for APIs in tomorrow's session, but it's usually used for unit testing where logic is right in front of us. But in regular system or legacy systems, depends on your point of view, logic is spread around. And when you're trying to say, well, I don't have a calculator, I have a distributed calculator with data here and setup here and controller here. So how do I map that? How do I think about what I've learned in the examples and take that into my real code? The other thing is that TDD, a lot of the examples that you'll see is that, well, it has a few dependencies, but you can mock them very quickly. Won't do any harm really, and that's not a real dependencies work. We may need services. We may need things that like if you're working with Spring is a dependency, but you can't get rid of it really easily. So and that really is a problem, because test-driven development is not only iterative thing and incremental. The idea is that you run the tests all the time. When you run all the tests all the time, you get feedback if whatever you've written works and you haven't broken anything. With all kinds of heavy dependencies, this thing becomes a lot slower. So again, you might think, well, it's not really for me. With legacy code, the code resists. You can actually feel you don't want to change it because you might break something. You might not have tests, because if you have tests, it becomes a lot easier to introduce TDD. But if you don't have tests, it becomes risky. You need to change the code in order to push code in, as you see in the examples. But this is risky, so you don't want to do that. And so you're fighting against the code, and finally you say, well, it's not for me. So what I'm going to show to you today is not TDD in legacy code, although it can work with that, but sometimes you have to do some kind of modifications. And the modification is not just for the code, it's in our mind. It's not like the cycle over and over again. It is about taking the test-driven development principles and applying them in different scenarios and keeping what the ideas behind TDD when Kent Beck invented it in 1997 are still true in our legacy code. So you can actually take these things and partly, if you think about how you're going to do it, think about the principles behind that, and then you can partially do this and do this successfully. There's one thing to remember. So we're going to go through a process of thinking, which I want you to remember. It's not something that we do as developers every day somehow, but when we're writing some kind of test, we're going to refactor something, or we're going to do these things, we're going to think about them as steps. And what is important is that while we're handling one step, try not to handle other steps. You'll see. So the first principle is when you write a test in test-driven development, you say what the pass criteria is. You write an assert there. Now, it makes sense, like with a calculator, right? 3 + 5 should equal 8. Well, you don't always know that up at the beginning of what the result should be. So let's give us the main example is the calculator, right? This is where you know 3 + 5 should be equal 5. But let's talk about the calculator or another thing, another logic that has a controller that has some logic in it. And this controller, the API's adapter for us, basically calls into this logic. So at the controller level, you know what the APIs are. You know what you get, what you call in, you know what gets out. But when you do that, do you know what happens at the logic level? The answer is not always. So when you're trying to change the logic and you want to write some tests around it, sometimes you don't know the answer. By the way, people who start test-driven development always ask this. how do I know what I need to see at the end? The answer is, first of all, you need to understand what you're doing and then decide how you're going to see it. Sometimes it's a method, sometimes you have to expose data, you need to do all kinds of things, but you have to know what you're working at. And this is step number one. Step number two is thinking about, well, the most important stuff for me is not to break anything that worked until now, especially in legacy code. Legacy code is code that is working out there. And whatever is working out there, and it could really be something that is working or something that is partially working, and it's still okay because the main part is that does work. So whatever behavior that we're going to do or we're going to add, well, it could be like a bug fix, or it could be a new functionality. Anything that worked until now should still work. And that's hard to do when you don't have any tests. Well, if you had tests, it would be easier. So while we're adding tests, we need to at least maintain the behavior that we had until now. By the way, if you go to the site, there's a new webinar I did just last week. You can see the recording about refactoring with this kind of situation. I'm not going to talk too much about it today, but if you're interested, go to everydayunittesting.com or testinggil.com. So that's the next one. Next thing would be refactoring. Now, everybody knows what refactoring is, right? You refactor, you don't change functionality. How do you know you don't change functionality? Well, we have tests for that, right? Do you have enough tests? Do you have enough coverage? It's a very big question. But that's not for today. What I do want to talk about today is that sometimes introducing new functionality or the bug fix or whatever code that you're going to do may require some pre-refactoring. So TDD talks about red, green, right? Red, write the test, green, pass the test, refactor comes at the end of the thing. It's true, but sometimes for the next test to pass, or whenever I need to, I want to introduce new functionality, I need to change the code. I need to do some refactoring so it would be easier. So I'm kind of extending the last part of the refactoring, but sometimes it's pre-refactoring. So we need to think about refactoring also not just as the end at the cycle, but also at the beginning of the next cycle. It might be like that. I'm going to show you an example for that. And then basically you do this, like you may not like work like regular TDD, like in regular TDD, classic TDD, when you're doing this over and over and over again, you get like every 10 or 15 minutes test passing. May not work like that with legacy code, but that's the idea. The main principles are there. You add test, you add the code, refactor, move forward. That's TDD. I'm going to show you two scenarios, really. One of them is a bug fix, sort of, and how it fits that. Everybody fixed bugs, I know. And the second one would be like adding functionality. And I'll go through the different steps and what do they mean and how do you apply it to TDD. I am going to use a calculator only. Mine's not a regular calculator, or a domestic calculator, and I'll show you that in a minute. Basically, it has two functions, like pressing keys and getting the display. Let's look at the example. So, demo. Encho. IntelliJ. Excellent. Okay, so what do we have? So basically, at the beginning, this is my messy calculator. It basically, logic part doesn't have any dependencies for this presentation only, because this will make it a bit more complex. This is complex enough. Why? You see this code here. So like I said, it has a couple of methods, press and get display is easy. Press 1. Well, if you know about code smells, there's something called arrow code when the code looks like this, like if. Yeah, that's kind of code, and it's not complete. It does something with plus and division. It does the equals with calculation, but it has some kind of rules that if you do 3 plus, it shows 3, stuff like that. Doesn't have any test though. Like I said, it doesn't do everything like a calculator should, and some of the things it does very badly, and that's things I'd like to fix. And that would be the beginning. So this is my code that I'm going to add a bug fix to and a functionality and operation types only support plus and div. That's the enum. That's all. And I'm beginning with nothing. I don't have any tests. So I have a bug, and the bug is that skip a bit. Give you a preview. So this is the bug. So if I'm pressing at the beginning plus, it should show 0, but this kind of breaks everything. So this is my calculator. Like I said, it's messy. I look at it and, well, I think I know where to fix the bugs, but that's not the TDD way. So the TDD way, write a test. But before we do that, like I said, I don't have any tests right now. Maybe I should protect the code in some way. So there is a way to do this, and the tests that I'm going to use are called characterization tests. Characterization tests basically capture the way the system works. And basically, this is a characterization test. So if I create the calculator and I do get display at the beginning, it should show 0. And if I press 3 after that and I get the display, 3. And this passes, obviously. But basically, I can write this and go to do the refactoring, right? Well, not really. Yeah, this doesn't cover everything. You've seen the code. So I'd like to do that even before I do the bug fix. I'd like to cover these things with more characterization tests. So I did that. And it looks like this. So basically, I have at start pressing and should show methods here at the bottom. At start gets the display, should show does the asserts. The pressing part takes a whole string, and like the calculator likes to be fed like character by character. So you see like this like calls press for each character. It doesn't really matter, but it is. So when I write characterization test, what happens is like this. I'll find things that work. I'll find things that don't work. And that don't work, I mean don't work according to the spec, right? So in my calculator, when I press 0 and then 3, the display should show 3, not 0, 3. But if you run this, you'll see that it's 0, 3. There are things that I'll find that maybe work, but maybe shouldn't. Like if I write 3 plus plus, this one passes, it shows 3, but I'm thinking, well, should it show 3? Maybe it shouldn't, doesn't should, I don't know. So when we're doing characterization tests, we kind of cover the code with tests, but we may find things that are not working according to our things, and then we need to decide what to do about them. And things that are working, and remember, we want to preserve behavior that we may not want to keep. So at the beginning, first of all, what we need to do is cover the code with tests. And like I said, these things don't work. So if I run them all the time, we'll get reds. We'll get failures. And I don't want to. So I need to decide what to do with them. My decision for this time would be, well, you know what? I'm going to ignore failures. That means I'm not going to run these tests anymore. It's a decision. I'm not sure it's a good decision. We can do other things with that. I refer you to my webinar, but today we're not. We're going to keep these tests. Right. So if I run this, I have good coverage, I think. I've decided with myself that it's a good coverage, but it may not be, and I may want to add a lot more tests here, but this is good coverage. Now I'm pretty certain that if I'm going to change things in the code, at least I'll know it broke something. So I have characterization tests. So next I'm going to the bug fix, right? Wrong. I'm going to write the tests. So this is a separate test. What I did here basically, and this is one of the things that I want you to keep in mind. Now I'm working on adding the functionality part. It's not a refactoring part. So what I did, I copied the entire, you see I have the should show and I have the pressing methods. I know I have them at the characterization tests level, but I'm not doing them now. I'm just thinking about adding the bug fix. So I have this test here, pressing plus should show 0. As you can see, it fails. Good. Why is it failing? Okay, let's look at the calculator. Well, you see that when you're pressing plus, it will go here and then call integer pass on display. But if we're at the beginning, display is an empty string, which goes boom. So that's the problem, right? What does TDD tell us when we're doing on functionality? Well, just add the simple things that could work. And I do that. So the fix is this. So the fix I thought about. So after the plus, check if the display is not an empty string. If it's not, go do this. And characterization tests work. That my test works. Excellent. What do I do now? Well, you see, I know the code. And you can see the pattern here repeats. So if it's plus, I added this and this passes a test, but you can see that the division and equals will going to be like, they're going to do the same boom because they have the same pattern in the code. Why? The code is duplicated, of course. I'm not doing anything now, but I sense that bug fix should not include just the plus. It should include also the division and the equals. So what do? Do I add the ifs? Of course not. Go to the test first. So a better fix would be to write these 3 tests. One for the plus, one for the equals, one for the one for the div, and pass them. And then again, simplest thing, don't try to do refactoring as we're going. Add the if, the ugly if, repeatedly, so the tests pass. And now I have my characterization tests passing, and I have my new bug fixes passing. We're green. Now we can do the refactoring, and you can see that this, if you look at these 3 lines, if you disregard the last operation part, this kind of repeats itself. So we can extract that into a function. So when I do the refactoring, it will look like this. So I extracted a method called parse key number, and it includes the check if the display is 0, and then it does the parsing. And that's pretty much okay. I fixed the bug. I fixed the bug very well. Code is not very well. Could be refactored as well, but if I'm pressed on time, I've done my job. Almost. So remember, I told you that I kind of copied the things. I had the characterization tests here, which had only the successes, but also the pressing at start and should know. And the bug fixes, just copy the implementation here of pressing and should know. Maybe I should refactor the tests as well. I can do that, probably should, because I'm going to have other test classes. So yeah, let's refactor the tests. And I chose to create a base class called the base calculator tests, which has the calculator and creating the setup in it, and the pressing at start and should. And now my tests, first of all, the characterization tests only include this because it extends the class. And I renamed my bug fixes class to calculator start test because everything about these tests is in the beginning, before calling anything. Tests become a little more cleaner, and that's cool. Can continue. Excellent. Push it, everything's okay. Push it and ship it. Now that's nice. Let me show you a scenario where we're going to add functionality. I think we're going to add functionality. Well, I'm going to start you the test that doesn't work that we want to add the functionality for. So right now we have the characterization test. We have the start test. But now we have something that doesn't work. Now, what doesn't work? The same behavior that now works for plus and div. If I press, for example, 9 plus, it will show 9. But I don't have any minus support. So I want to add that. So I wrote the test, but as you can see, it doesn't run. And the reason it doesn't run, look at the code. I can add more ifs here, but you can see that this will become uglier as we go. So I'd rather do some pre-refactoring first. So I'm going to use the test that I've collected until now to do some refactoring. And I do it in a couple of steps. So the first step would be to add guard clauses. Guard clauses is a way to cut down on error code. So guard clause basically means if I return from this, for example, from this block, I don't need an else here, because it will either return from the if block or continue. So first of all, I'm going to add a guard block, and it looks like this. So I add it to the if, a return, and I don't need the else if here, just the if. And I can continue doing that, by the way, but I stopped with the guard clause here. Next I want to do is like extract the application, like these things here. Basically the same thing, but only with a different parameter, right? So actually, before I do that, I'm going to replace these things with a switch. That's the order. So usually a way to cut down an if block is with a switch, right? So case plus, it's, by the way, I designed it this way because this is how you can actually see better that the code is duplicated. So I have the plus, the div, and the equals, and the default, which is what happens when you actually press numbers. And why am I going this way? Well, you know, I'm trying to sort of extend an existing behavior towards a minus that doesn't exist yet. So making that into a switch would make it easier. Next, I'm going to extract these things into methods. So all the time I'm running my tests to make sure I didn't break anything, because now I have tests, both the characterization and the ones I've collected in the bug fix. So I created a handle op method here, extracted this, and now, because I know the code, adding something with the minus would be a lot easier. To put just creating the new operation type enum and calling handle op with it, right? Can just add it to the code, right? Wrong. I'm going to add a test first. So once I do that, I can undisable my test. So now this runs. Obviously, it fails because it doesn't have the minus stuff in it. So I've added the minus here, and it's easy now to just add a case minus because I did the pre-refactoring. It's less risky, obviously. And the code now just shows me what to do. And now my test passes. All my tests passes. You see, it's green. The final part I want to do is refactor. Now, these things, you look at this code. That's okay. Yeah, we did a lot of the heavy lifting with the pre-refactoring, and it worked because it was easy to add the new code in it. But let's do a bit more. See, I talk about in clean code about code who speaks in two languages. And you can see that two languages here. This is one kind of language. It's a high-level language called handle op. If you want to see the details, go check the method. But this one and this one is another language. It's more explicit. It's more detailed. So why not abstract these two and extract them into other methods so they will speak the same language? So I'm going to extract the top one to a method of itself, and then this one to a method by itself. And it will look like something like this. So that's the final code. I can even do something about this. So my switch now does the handle op on these things. And you can already imagine how multiply will work. And I have case equals with something called handle equals, which I extracted here. And the rest, the default called handle numbers here. And now you can see that with further things that were actually failing at the beginning, it's easier to fit in the new code or the bug fixes, because the code is a lot better. I've refactored it into different parts that make sense. The whole press method now fits into one screen, which is kind of magic. And you know where the next operation goes. You know what happens when it's not equals or numbers, for example, like the C. If I want to switch that into the C, I will put that another case in. And you can see that I've already categorized things like the operations and equals and numbers, because I know that they work differently, not just in the code, but also in the domain language. In the domain, these numbers work differently. So I took a lot of basically the basic principles of TDD and applied them in different ways to the different steps that I'm working on. The first one would the risk part, add some characterization tests, and then the test first part, write the test before it works, and do refactoring on all kinds of things on the green while everything is passing. Don't mix the two. Going to get back into my slides. Right. So this was the demo. So I want to go back to the points and what is important, and to summarize what we did. The most important, I think that the most important stuff that you want is not to break existing behavior. And if you have tests, you will know because you run the tests. If you don't have tests, you won't know, and therefore you have to create the test. So that's the first step. When you're going to apply any refactoring or new code to existing code, you want to minimize the risk. It's not like I'm telling you something new. You know that. But now you've seen characterization tests, and you can read about this more and check out my site for that, how to do this more thoroughly. But you need to start with that. I don't want to break stuff. Therefore, I need to cover it with tests. How do I do that? What is the right behavior? What happens when I don't have it doesn't show the right behavior as it should, because it's not built like that. Somebody built a hack like 3 years ago. That's how it's working now, and it will fail my test. What do I do with it? And you have to decide what you're doing there. I chose today to disregard bad behavior, but there are other ways to do that. For example, you can use tools if you're using if you know approval tests, or if you're using in JavaScript Jest, for example, they have template-based tests. So you throw data on your system, see what comes out, capture it in a file, and compare. And as long as the file is the same, everything is okay, depending to your definition what everything is. Like I said, a whole webinar on this on my site. First thing, minimize the risks. So that's adding more tests. The second thing that is really important is when you're working on something, know what part you're working on. And this could be like either changing functionality or not changing functionality and refactoring. If you mix those together, the signals that you're going to get from your tests are going to be confusing. Something broke, but you don't know why, because you both refactor and change functionality. What broke it? By the way, one of the things that makes this easier is to do changes like I did in very small steps and run the tests every time. Not do the whole refactoring together. You can, but do a bit of refactoring. If everything works, move on to the next stuff. And when you're going to say, well, I'm going to change functionality, that means you're no longer refactoring, and therefore your tests are bound to break, maybe. What you want to have is like in TDD. The new test should fail while the others should break. It may not work. It may not be that you have to change a lot of things in order for the other tests to work as well. But you need to know that you're currently working on the functionality changing, and therefore it's going to break, and that's okay. But I'm not going to do refactoring what I'm doing that because I'm focusing on changing functionality. So the separation that TDD does so well, and it's built into that cycle, that here you focus on changing functionality, here you're focusing on changing the form of the code, and you're not mixing, and you'll get the right signals from your tests. And it's easier because it's easier to focus on what we're doing, and while you know what you're doing, the signals are much more clear because you know how to interpret them. Less debugging, really. If you work in small steps, by the way, there'll be a lot less debugging, because if everything that you're doing is small steps, then you know what broke your code or your tests, and then you can just undo it. And if you're working in a cycle in very small steps, that means undoing stuff doesn't lose a whole day's of work, but just minutes of work. Don't need to debug like a half an hour or something that you added 2 lines of code with. Just remove the 2 lines of code. So that's a separate thing, but it works as well. By the way, TDD works this way. It doesn't say small steps, but it does say do the simplest things that works in order to pass the test, right? Why? Because if it doesn't work, you don't need to debug everything. Final thing, principle, the TDD doesn't talk about this. It does have the refactor part. It doesn't say keep the code clean after you're done, but it facilitates this thing. Once you have the tests around your code, you can say, well, it's safe to do some cleanup that may not be part of what I intended to do, but I can do that now. Like the things that I did with the 2 functions, extracting it, because I can do it safely. If I can do safe things in a safe way, I will do them more. And creating clean code out of legacy code is something that you probably want to do. And if you go this way and add some tests, you're more inclined to do that. And that's a good thing. So what I showed you today is basically taking TDD as the theoretical thing, like the cycle, and I broke it down into different principles, and I showed you 2 scenarios, simple enough for today because they need to fit into this 45-minute thing, but you can apply them in other scenarios as well. Something failing, write a test. It doesn't really matter if it's a unit test or an API test or an end-to-end test. Write a test, think about how it will look when it's going to pass, but do it first. Then you write the assert, and then make it pass. Could be like a bug fix, it could be like a new feature, it doesn't matter. Write a test first. Separate the thinking between the functionality and refactoring, and do it over and over and over again. This is how I write software today. This is the best way I know to move ahead the fastest I can with productive code and production code. Productive means working code that works over and over and over again. If you haven't tried TDD until now, because it doesn't look like it work in your code, I encourage you to try it. Find a piece of code and think about the principles and decide what you're going to do, whether fix a bug or add functionality. Write a test for it, pass it, refactor, and if you are writing something on a risky thing, start with writing some characterization tests first. That's basically it. So this is basically what I want to show you today. Tomorrow I'm going to show you how to build with test-driven development APIs. Not like a unit test like I showed you today, because it is possible. So here are the things that the ways that you can get in touch with me. But right now, if you have any questions, put them in the chat window and I will look at them and I will try to answer them. But if not, I hope you have the great rest of the day. And that's basically it. And I hope to see you tomorrow at How to TDD a REST API. Thank you very much.